Great insights.
Yeah, maybe
All right, go ahead,
can
Payman. I'm
talk
sorry,
about the
didn't mean
AP
to.
density.
No,
Yeah.
yeah, sure. So I think Dan talked about this earlier, and also Roy mentioned it. So for a location deployment to work well, you need to have enough anchors because the location is computed relatively to those anchors. So here in the next two slides, I talk about that. So when we went from I'm just talking about the journey of density. So when we went from APs that had only 2.4 gig and 5 gig to APs that had 2 gig, 5 gig, and 6 gig, we changed our deployment guides. And because a lot of actually 6 gigahertz, well, for 6 gigahertz have higher frequency, the regulation around 6 gigahertz is different. And there are a lot of 6 gig clients that today are low power indoors. And they don't use the standard power. So they're on with the 6 gig capable APs, the density requirement we suggested was 1 AP per 1500 square foot, so you get good 6 gig coverage. Then I think that's what we call here a standard density. It is designed for connectivity. Then for those same APs of a generation ago, before Wi-Fi 7 came in, if you want to have good coverage, you need to place, well, you want to have good location, you need to place the APs on the perimeter. So you look here, right, in this diagram, what we have, on the left is network design for connectivity, and this is for 6 gigahertz connectivity. So we have this is just an example, right? Like to show how the AP counts change. So we have a rectangle 200 foot by 200 foot, and we're putting APs 40 feet apart on the very left for good Wi-Fi coverage, right? But then you look here, there is no AP on the perimeter. So if you put an asset tag on the perimeter, and especially if you're trying to compute the location using RSSI, the ones that are outside of what we call convex hull, you don't get good location accuracy. Right, so when you come to the middle one, what we're doing is we get the same distances, but put the APs on the perimeter. Now everything you have here is in the convex hull. And convex hull is just the smallest polygon that, has all the APs inside. So now if you put an asset tag in the middle here, anywhere in this rectangle, it is in the middle of the APs. So the location can be computed, which is important. So now, as we go to the one on the very right here, we have reduced the distances of the APs. And why we're doing that are multiple reasons. But since we're talking about ultra wideband here, now ultra wideband transmit power is lower than Wi-Fi transmit power. It is a 500 megahertz signal which is sent in a band that there are also other technologies there, primarily outdoors. So the transmit power is lower. What that means is the range is less. So as a result, you need more anchors, and the anchors for us are APs. So we are reducing, the distance from 40 feet to 30 feet. So if you look on the left side, you have 25 APs, and on the right side, you have 49. So the number of APs need to increase, right? But then when you do that, you don't have to deploy an overlay of anchors. If you go to a lot of manufacturing floors today, they have Wi-Fi APs. They also have location anchors. And you could also find that in healthcare in many places. So there are two technologies involved in parallel, which is hard to maintain. You have to have two networks, two management, two different things. What we're doing here is increasing the density of APs, and then we do all of it with one infrastructure, which we can manage, do it securely. And then with the capability of Cisco spaces, we could produce the location outcome, occupancy data, and all of it. You can also do indoor navigation because we have the maps, and the phone can get the maps and all of that.
Yeah.
And these are kind of design generalities, right? These aren't specific necessarily in all cases. There's not a hard fast number. But if I wanted to design a location, is it possible that I could, like you're showing, maybe 49 APs to get UWB and 25 for coverage. Maybe if I don't need UWB accuracy, that, centimeter kind of accuracy, right? Sub-meter accuracy, we'll say, can I do a hybrid design where I have, really good location in certain areas and maybe not as good in other areas and that sort of thing?
You absolutely can.
Okay.
And and to what Roy was saying earlier, if you compute the location accurately in one place with ultra wideband, that location is tracked, by the phone. Phones are pretty
Ah,
smart devices, so it will be accurate for a number of meters,
right.
right? And
The
the
phone
other
has the
piece.
inertial capability too. Yeah, right. Yeah, exactly.
Exactly.
Okay.
Actually, phone
Interesting.
is like the beauty of the phone is there's so many technologies in it. So the phone and with what Roy have developed, they're all fused, right? The other piece of it is, which I want to emphasize, like let's say you have an electric room, concrete all around, right? So wireless does not penetrate to reinforced concrete. That is, true for Wi-Fi also. But with fusing, you could figure out your way in and out of that little place, right? But then the other piece of it, Ali, is if you are in a manufacturing floor and you want to know where something is exactly, then you do want to put an anchor in any area that's critical. So you may deploy a lot. And then to your point, when you get further apart from the manufacturing line and you only need Wi-Fi coverage, fine, you don't need location accuracy, just put an AP for Wi-Fi
Yeah.
coverage.
Interesting. Thank you.
Sure.
And just to add further, as Peiman mentioned, in order to assist our customers, Cisco sales teams, and partners to understand how the location context-aware deployment would look like, we work with Cisco Spaces to build up a Smart Spaces Studio tool, which can help designing your network. So next, I will show how that works. So let me pull it up. So the first thing, it asks for the use cases. So we can select all the potential use cases we're looking for. Let's say we want to do some indoor navigation and asset tracking with ultra wideband. We go next. And we can select any of the sample buildings or floors, or we can manually enter the square footage of our building. Let's say if I put 50,000. And then this is something really important. So basically, all these technologies, they are really kind of like uh, they depend on the environment of the building or the floor structure. For example, if it's an open layout, which is kind of like a showroom, an event hall, or is it a fully enclosed building like a surgical suites or executive offices? So that would actually change the AP density. So if I select open layout, and let me see the recommendations. So this tool would give me some recommendations on the Wi-Fi access points. For example, I could probably use 9176 or 9178 access point, which have the UWB capabilities. And then this is how my layout should look like. So basically, I would need like 50 APs, and the recommended coverage per AP is 1,000 square feet. Another important point I would like to make here is, like as Peiman mentioned about the convex hull and convex zone. So basically, when we talk about the APs that are closer to the exterior walls, they shouldn't be further than 5 to 10 feet from the exterior walls. So this is something important. So for example, if there's a phone or a tag getting closer to the corner of the building, so it should be able so tags should be heard by at least like 4 access points, neighboring access points. So this is how the deployment should look like.
Gotcha.
Yeah.
Okay.
Yeah, so that's all we had
Nice.
for today, and we're open for
And
questions.
we've even seen some of the RF propagation vendors, the guys that do like AP planning and stuff like that. They're starting to add ultra wideband capability also, right? So we're starting to see that you can
Yes,
actually do
yes,
RF planning.
we
Yeah,
are
RF.
working with them directly on this. Yes.
Yeah, we are
Yeah,
working with both Ekaho and Hamina, and we are helping, putting the right models in them for our APs where they could use Wi-Fi to plan UWB deployments and then validate it also.
Yeah.
So you plan and install and then do a site survey if you need more anchors or need to move an anchor. We'll using those tools, we can guide the customers.